Hello everyone and welcome back to another video. Today we'll be taking a look at another British Informatics Olympiad question, and we'll be taking a look at the 2017 paper and the second question from it. So I'll just let you have a quick read of the question before I jump onto the solution. Feel free to pause the video and just have a read of this. Okay, so then now I'll explain what the question exactly means and as well as the solution. So pretty much what the question wants us to do is model a certain situation of this game. And in this game what we do is we basically connect two dots to each other, and these dots are basically decided using some sort of set procedure. So and the way in which they're done is there are two players and each of them have a certain modifier and a certain position. So their starting positions are, let's say, like 3 and 10, and their modifiers are 4 and 5. So what this means is that they initially start with position 3, and then on each subsequent turn, they go 4 places to the right. And then, so for example, 3, this would be 4, 5, 6, and then this over here would be 7. So then in their next turn, they would start with this square, and then carry out the exact same procedure. And now the procedure is what we will be describing exactly right now. So what they do is they basically select from any particular edge, let's say this particular edge over here. They first check upwards whether the edge connecting that particular dot to the one above it is free. And then if it's player 1, then what they do is then they check the one to the right of that, and then down, and then left. So they basically proceed in a clockwise fashion. If it's the other player, player 2, then they proceed in an anti-clockwise fashion. Okay, that's the only difference between the two players, as well as the modifiers and positions which they have. But now let's actually jump on to how we're going to represent this inside code, basically. So what the question states is that each of these are represented with a number, 1, 2, 3, and then this goes 4, 5, 6, etc., and then 7, 8, 9, 10 on the next row, then 13, 14, 15, etc., etc. But then representing these as numbers isn't actually the most convenient way to think about them. The reason for this is because each of these dots are basically just like a pair of coordinates, right? A pair of xy coordinates. If we represent them with a number, then certain things become very tricky. For example, let's say for the 7 number, if we were to represent them with numbers, then what we would say is that the position above it is the number -6, the position to the right is +1, and then +6 and -1. However, for the 7, the position on the left of it, that is not 6, since there's nothing on the left of it. But then with coordinates, this is very easy, since we could represent 7 using the coordinates, let's say 0, 1, sorry, 1, 0. And then this provides us a very, very easy way of representing it, since we know that if this is the 0th column, then you can't have the -1th column. Similarly, you can't have the 6th column, okay? So this basically provides us with limits as to our coordinates, and that is incredibly useful in this problem. So the way we'll represent all of these is with coordinates. This initial one is starting as 0, 0, and this final one is basically 5, 5. Okay, and now these are the rows, these are the columns, sorry. So these increment 0, 1, and then this becomes 0, 1, 0, 2, etc. And then these are the rows, so it becomes 0, 0, 1, 0, 2, 0, all the way, and then 5, 0 at the very bottom, and then 0, 5 over here. Okay, so this basically provides us some sort of representation to represent each of the coordinates. But then you might be thinking, how do we represent a connection between 2 points? So the answer to that is that we just have 2 pairs of coordinates. So for example, for this particular connection, this coordinate would have 1, 1, and then this one would be 2, 1. So then the way we represent this connection being present is we have an array of connected elements, and in that we append 1, 1, 2, 1. And that can be one connection made. However, since this connection is both, like, it occurs in both directions, so we would also append 2, 1, 1, 1 to our array of connections. And now these two become the 2 connections following this particular edge which has been connected. Okay? So, and now one final challenge which we have is deciding how exactly squares are going to be decided. So how do we decide that this particular square is now filled, for example? So the way in which we do that is we basically check. So for example, this 1, 1 and 2, 1 connection, we need to check whether 1, 1 is connected to 1, 2 onto the left of it. And then we need to basically check for square connections around the edge which we've connected. So let's have a quick look at an example. Okay, so I basically just pulled up an example over here. So let's say that this orange connection is the one which we have added on in this particular move. So we need to check whether this is part of any square. So since it's a horizontal connection like this, there are two squares which it could possibly be a part of. One is a square which is above it, such that the horizontal edge would be the bottom edge. And the second one is the square which is immediately below it, such that the horizontal edge would be the top edge. So the two coordinates of the horizontal edge are 2, 1 and 2, 2. Since it's a horizontal edge, then the two squares which could be formed are 1, 1, 1, 2, 2, 2, 2, 1, or 2, 1, 2, 2, 3, 2, and 3, 1. Okay, so these are basically the two possible squares which can be formed. So then it would be different if the two edges were vertically connected though. But then for this particular example, we're just looking at horizontal edge. So then how we check is that let's say the edge which we connect is xy followed by xy plus 1. So we basically need to check for the following connections. We need to check is x connected to x plus 1, y plus 1? Like, are these two edges connected? Additionally, are these two edges connected? X, y plus 1. If these two edges, and these two edges, if all three of them are also connected, and then we know that this edge must be connected since that's the one we're appending onto the list. If all three of these pairs of edges are also connected, then we know a square is possible. And likewise, we have one just below it as well. Instead, we go x minus 1, and then x minus 1 over here. But then it's the exact same logic. We basically just check whether there's connections present between each of the four edges inside the square. And then if that's the case, then a square is basically formed. And now if a square is formed, if you recall from the question, that basically means that that particular player gets another move. So, and that's also how we increment the points of each player. So now let's have a quick look at the actual code required for this question. Okay. So pretty much, there are a few main functions here. There's the first one, which is just the initialization, but that doesn't really count. But then after that, there's is square formed. So exactly how I described on the whiteboard right now, we have a function which decides whether a square has been formed from two coordinates. And the second one is move. So this move is basically just carries out one move for a player. And this basically consists of adding the modifier to the position and then searching for which edge is most suitable to be connected. And then we have the play function. So the play function just ties in the move function and the is square formed as well. And finally, we have output, which is required for us to display which squares have been occupied by which player. Excuse me. So and now let's have a look at the is square formed. This is the main function inside the code. And so pretty much how this works is here are basically the pairs of coordinates which are passed, as well as the color. Color is basically the person whose move it is. Color or player doesn't really matter, but I've chosen color as the parameter name here. And this possible is basically just an array of all the possible squares which could be formed from two possible coordinates. So if the x-coordinate is equal to the x-coordinate of the first one is equal to the x-coordinate of the second one, that basically means that it's a horizontal connection which is being made. So then these are basically our possible squares. So what this means is xy to xy plus 1. So if this is xy, then xy plus 1. And then the square which is above xy plus 1. Then the square which is on the left of x plus 1, y plus 1. And then this square should be directly above this square. So if you're not very comfortable with this, just I recommend drawing it out on side, like on a piece of paper. It'll definitely help you visualize where exactly these coordinates are coming from. And then the other possible square, which could be as a result from this horizontal connection, is basically the square which is below it. So instead of plus ones, we change them to minus ones. Okay. And now for the vertical connection, we basically have, instead of incrementing the y values, we increment the x values over here. And like exactly as before, I'd recommend you just draw it out on paper, and then you'll immediately understand where these numbers came from. And now, if you're wondering, there's also this second piece of information for each of these possible ones, and this is basically what the top left, what the coordinates of the top left square are. And this will come in handy a bit later on, but so I won't go through it right now. I'll go through it in a few minutes. So pretty much what we do over here is we basically just go for each element inside possible. So that's basically this whole thing. And then the array is these four elements at the edge of the squares. And the top left are the coordinates of the top left corner of the square. And now the reason why we need to know the top left corner of the square is because pretty much the question requires us to output the entire grid, as you can see over here, in a 5x5 format. So this is basically the grid of all the occupied squares. And now each occupied square can basically be represented with its top left corner, since each top left corner corresponds to exactly one square, and then each square corresponds to exactly one top left corner. So that provides us a perfect representation as long as we have the top left corner, if that's what we're considering. Okay, so we basically have the top left corner passed to, as well to each four pairs of points inside the square. And then we basically make result, we set this flag variable to equaling true. And what this does is this basically checks whether there's if there's not a connection between any of the edges inside the square, then we basically set this flag to equal false, and then we break out. But if this flag variable is never set to false, then we basically know that a square must be formed. Hence, we set that particular element inside this grid to being equaling color. So this indicates that a certain color has occupied a certain square. And then we increment the count. And the count's basically just the count of the number of squares which have been updated. This is either 0, 1, or 2, since you can either have 0 new squares from remove, 1 new square, which means that either one of these has formed a new square, or both of these have formed a new square. So 0, 1, or 2 is basically the count. And then whatever that count is, we just increment that to the points of the corresponding color. Okay? So that's basically the is squared form function. And now the next function which we have is the move function. So what this does is this basically carries out a move for a particular player. And what we do over here is we start by incrementing the num, where num is the number of the position, to equaling the positions plus the modifier of the positions. But now you might be thinking, you know the num which the question gave us, how do we compare that with our coordinate system which we've represented this grid by? So the way we do that is we basically, the row value would be num minus 1, and then whatever the quotient is when divided by 6. So if you think the first row, that's made of 0, 1, 2, 3, 4, 5. So the quotient when divided by 6 is basically 0. The next row is 6, 7, 8, 9, 10, 11. The quotient when divided by 6 is 1. So that provides us a perfect representation of all the rows. And the column value is basically num minus 1 mod 6, so the remainder when divided by 6. So the first column would basically have a remainder of 0, second would have a remainder of 1, etc. So that's basically how we represent the chords. And then we have the dx dy. So what this does is this is basically just all the neighboring elements. If the player is basically 0, then we iterate through clockwise. So then the change in x would basically be minus 1 since it goes up a row. And then the change in y would be 1 since it goes right a row. And then 1 and then minus 1. So, and then it's pretty much the opposite orientation for if the player is not 1. That's how we determine the 4 neighboring coordinates. Okay? So, now we just iterate through each of the coordinates, clockwise or anti-clockwise depending on the player. And then we basically set new chords to equaling chords plus whatever dx and dy we have over here. And now if the chords, new chords is not in self-dot connected, since remember each edge which we're basically implementing has to not already be an existing edge. If it's not already an existing edge, and this is fundamental, and the new coordinates is basically within the grid, because if it's not within the grid, then it's not valid. For example, for the top left point, that doesn't have a set of coordinates which is directly above it. So that would not satisfy this condition. Hence, this condition is only satisfied by valid numbers, which can be appended to. And now, if it's a valid number, then what we do is we append that connection to connect it, and we append this both ways. So a connection is basically from chords to new chords, as well as new chords to chords. And now, if dx or 1 is greater than 0, or dy1 is greater than 0, this basically means that the square formed, what we do with the square formed is, I've added a little comment here as well. The chords 2 is basically greater than chords 1. Since we have two possible positions for the coordinates, either they're both vertical or both horizontal, but either way, there's going to be one which is greater than the other, like one which has a value which is greater than the other. So in this case, just for ease, I've set chords 2 to being greater than chords 1. This basically prevents us from having 4 conditions, instead we only have to have 2. So the way we decide if either dx is positive or dy is positive, then chords 2 will be greater, so new chords is the right one. Otherwise, new chords will be the left one, because chords is greater. So that's basically how we determine which square is formed. And now, if square formed is basically going to be, it's going to return from is squared formed. And then is square formed just returns count. So this also returns count. And then this is later than the call to the play function. But then let's say there isn't a possible edge connection in each of the 4 directions. Then what we do is we basically go to the next number, so we increment number by 1, and then we repeat this entire thing again and again, which is why we have this while true. But then our break condition is basically as soon as we made a move. And then that's pretty much it for the move function as well. And now we just have the play function, which puts both of the previous functions together. So while the turns is greater than 0, we go through each of the players, and then we basically set square form to equaling true. So this is basically just this is just so we can get inside this while loop. And now once we get inside this while loop, what we do is while the square is formed, i.e. like while a square has been formed, we basically carry out a move for the function. And now this flag, this basically tells us how many new squares have been formed as a result. And now if the result is greater than or equal to 1, which means a square has been formed, then square formed will be true. And what this will mean is that the player has one more turn, which means it re-enters this while loop. And it keeps on re-entering this while loop until like all of its until it makes a move which doesn't cause a new square to be formed. And then at that point we basically go to the next player, and we continue doing this until all the turns are up. And now if turns is equal to 0, or it's less than 0, which is invalid, then we basically break. And that's pretty much going to be it for the play function. And now finally, just the one final function which we have is the output function. So what this does is, if we go back to the start, we initialize the grid to being 2 for each of the 5x5. 2 corresponds to a neutral color, basically. This means neither player 1 nor player 2 has had that particular square. So that means that a color of 2 means asterisk, it's not occupied by either player. Otherwise, a position of 0 means it's occupied by player 1, and 1 means it's occupied by player 2. So we have these corresponding symbols, and then we basically just print off the symbols in each of the ones, and there's just a bit of code to actually print it. But then that's pretty much going to be it for the output function. And that's basically it for this entire code. It's between these 4 functions, and then all we have to do is just take in the parameters as input, and then call the game function, and then call the play function with the number of turns required, and then just printing off the number of points. So that's pretty much it for this particular code. Now let's see if our code does actually work, and we'll test it on some of the sample test cases provided. Let's start with this particular one. And now let's see if it works here. Okay, so this basically gives us 1312 as well as this orientation. Now if we go back to the question, 1312 and this orientation is indeed correct. And we'll test it on one more. We'll test it on the final one as well. Also, I should mention that in case you would like to do the code yourself and just have a look through it and play around, there is the link down in the description below. That's basically to my GitHub, where you can look at the code for such problems. Okay, so 25 in this particular output, and then we can see that that is indeed correct. So our program does indeed work, and that's pretty much it. So I really hope you enjoyed watching this video. Hopefully you learned something new. If you made it to the end, thank you very much for watching. Feel free to check out other British Informatics Olympiad videos on my channel. I've pretty much done almost all the questions. And yeah, I thank you very much for watching. Hope to see you another time. Bye.